Before we do that, is there anything anyone wants to bring up or remind us about? Okay, we'll get going then. So we might as well start off at the southern sky. So the time is just set to the system time, which is now basically, so the view will be similar to what you'll see a bit after 8 down at the regional park if you're down there. So I'm going to, so we're looking into the southern part of the sky, and I'm going to zoom in and we'll pick on Crux actually as their first constellation to look at. There's a few things about Crux I was going to talk about. If we look at A Crux or Alpha Crucis, so I believe A Crux is the official name of the star now. And if we zoom in, we can see what appears to be another star. You can see that star quite easily in binoculars. So it's not part of the same system, it's just an alignment. But if we keep zooming in, Stellarium doesn't show it, but it is actually a binary. You can see it at high magnification, so have a go at that. The other star in Crux that is quite interesting is Mimosa. And you notice that it's showing as quite a bluish looking colour the way it's being rendered here. So what Stellarium is trying to show is basically the stellar temperature. So to be blue like that, compared if you look at GA Crux up the top there, is sort of a more yellowy sort of colour, so that's going to be a cooler star, whereas Mimosa is a very hot star. In fact, it's one of the hottest stars that you'll see with the naked eye in the sky. And the curious thing about it, we zoom in, and this is a fun thing to try and see in your telescope. There's a big brightness difference, but in the same telescopic field as Mimosa or Beta Crucis, there's this star here, which is DY Crucis. Mimosa being one of the bluest stars in the sky, this one is one of the reddest right next to each other, which is quite interesting. DY Crucis, as you can tell from the nomenclature with 2 Latin letters like that, indicates it's a variable star. So the colour does actually change. It goes through, not only changes in brightness, but changes in colour as well. It's a pulsating carbon star. Of course, as it expands, it cools, so it becomes more red. And then when it contracts, it actually dims, but it becomes less red. So it's quite an interesting phenomena with these pulsating stars. But just to see the contrast between the 2 stars, it doesn't really show it the way it looks like on a telescope on the way it's rendered on here. But it's quite a fascinating one to look at. And of course we have our favourite object, which is quite only maybe, or it's within the same binocular field for sure from Mimosa, as you have this nice star cluster here called Kappa Crucis, or the jewel box or jewel casket sometimes. It's a really nice little cluster of stars. The name was actually coined by John Herschel when he completed his father's work of surveying the entire sky. He came down to Cape Town to complete the Southern Hemisphere survey. So a lot of the things in the NGC catalogue were discovered by the Herschel family. In fact, most of the objects in there that Dreyer put in there, the Herschels were the main source because it was done before photography. Okay, we'll zoom out. Another feature that you can't see at all in the city, but you'll definitely see down in Waharau with Crux, is you see I'm not sure how well it shows on this screen. You can't, I'll have to come out here to have a look. No, it doesn't render very well, unfortunately. But it shows up better on here, where you can see sort of surrounding Mimosa and running to about the long axis line and the cross. There's a sort of a dark patch of the Milky Way. And it's,
turn up the brightness of the Milky Way?
Yeah, I probably could have a look at that, see whether it'll let me do that in the settings. Yeah, it's unfortunately, even though it's showing quite well on here, it isn't on the external monitor. What do we want? I don't know if I can control the brightness overall, but I might be able to somewhere in here. DSO. Oh, under sky.
Milky Way brightness on one.
Oh, yeah, sorry, I see. Let's try that. Trouble is we can't see it. Oh, yeah, I can see it on here. Oh, that's better. Yeah. Thank you for that. Yeah, that's you can definitely see the dark area between Acrux and Mimosa there, known as the coal sack. It's basically, you've got all the faint stars of the Milky Way, and then the dark area is not an area where there's no stars. It's just a nebula consisting of dust and gas that's obscuring the background stars. And you'll notice if you're at a dark sky site, it's quite obvious just to the unaided eye. Okay, before we leave Crux, has anyone got anything they'd like to mention about it, a favourite? Or I think I've done the brighter, more obvious things. Oh, well, yeah, I haven't done Centaurus yet, but we'll do Centaurus next. So you see these two stars, you've got Rigel Kentaurus or Alpha Centauri and Beta Centauri. If we zoom into Alpha Centauri, it's the closest star system consisting of 3 stars. There's a faint star called Proxima Centauri, which is a red dwarf, something like 12th magnitude. So you can only see it in a telescope anyway. So could be a challenge on the weekend to try and find it, especially if you haven't got a go-to scope. But if we zoom in here, I'm hoping, yes, sort of you're seeing it start to split them. They split in quite easily in a telescope if you've got a reasonable aperture. So there's actually 2 stars in that system, Alpha Centauri A and B. Alpha Centauri A is slightly brighter than the Sun and B is slightly dimmer. So our Sun is about midway in brightness between the pair of stars that orbit each other with a period of about 80 years. So the orbital periods are not far different to the outer planets of our solar system. So, yeah, if you observe them over a few years, you'll see a noticeable difference in the orientation. So that's not something you're going to see in one weekend, though. If we now follow the line between Alpha Centauri and Beta Centauri, hang a left towards this star here, Eta Centauri, and we keep going about another half, or just over half of that distance again is the object that Robert was just referring to, is called Omega Centauri star cluster. It's relatively easy to see in binoculars. In fact, it's possible from a dark site to see it with the unaided eye. You'll just see a fuzzy star. If we zoom in, we get roughly what you might see from a dark site in a large aperture telescope. The cluster has something of the order of 1 million stars in it, and it's thought that it's not a normal globular cluster because it actually has more than one population of stars, so it went through multiple star-forming episodes. So for that reason, it's thought that it might be the remnant core of a dwarf galaxy that was captured by the Milky Way a long time ago. Either that or we don't know too much about the way globulars form. If we, it's definitely worth a look. the way I sort of describe it, because the individual stars are quite faint, but it kind of looks almost, if you imagine the stars being sand grains, it looks a bit like that. Somebody threw a pile of sand on the floor and it's just a big blob of stars.
The other description is diamonds on velvet.
Well, that's a bit more poetic than what I said.
Bill, that's actually in the Milky Way, is it?
Yeah, well, it's not in the disk of the Milky Way. It orbits the Milky Way core.
Oh, I see.
That's the interesting thing. All the globulars, there might be some passing through the disk, but they're not actually part of the disk. They basically orbit in sort of random orbits around the core, and some of them are at fairly steep angles to the plane of the galaxy. It's believed they formed very early when the galaxy was first forming. There's about 170 of them. And the interesting thing is that there was a big argument in the earlier part of the century about the nature of the Milky Way. One of the things that was worked out is that when you catalogue all of these globular clusters, the bulk of them are on the side of the sky where Sagittarius is. And that's how they work. That's where the galactic core is located. Because if you're looking out towards the Orion side, there's actually very few globulars seen out in that direction. And they're almost like I don't know what you could imagine, a cloud of mosquitoes buzzing around a light bulb or something being the core of the Milky Way. And generally, they're very old stars. There's a few funny things about them, because you'd expect, being old, there wouldn't be any stars with a high surface temperature, no blue giants or anything like that. But there are some of the clusters do have bluish stars in them. It's believed that they formed from mergers, because these things are so dense with stars that occasionally you do get stellar mergers in the core, and it's believed that's where these bluish stars are called blue stragglers. And if you draw a Hertzsprung-Russell diagram, you see the main sequence with the cut-off, so there's no really bright hot stars except a few stragglers. So that's where the name blue stragglers comes from. Okay, we can actually carry on the same line. And here we have a galaxy, the Hamburger galaxy. If you came to Rolf's talk last week, one of his images featured this galaxy, Centaurus A. You might think, oh, it's got a funny name. What is it called? A, and it refers to it's being a radio source. So it's basically the letter A as a radio source is the first radio source known in that constellation. In fact, I think this was the first extrasolar system radio source ever detected. Does somebody know that for sure? And it was, believe it or not, detected in New Zealand out at Piha. After the Second World War, some people set up some old radio gear and used the sea as basically a mirror reflector. And they realised there were radio signals coming from this part of the sky, and it was identified with this galaxy. So we'll actually centre it. We won't have a picture quite like Rolf's, but there we go. It's got the dark lane. You should be able to definitely see the glowing sort of elliptical type galaxy surrounding a dark lane. And it's believed the dark lane is gas that was stripped off a smaller galaxy, that probably a small spiral that was merged with this one. It's quite a bit larger galaxy than the Milky Way in terms of mass. So we used to be able to see it here. I remember years ago you could see it in the Zeiss, but I can't see it anymore. And I don't think it's just because my eyes are getting bad as I get old. It's just the sky glow has got worse over the years, and there's no longer enough contrast even in the 20-inch Zeiss telescope to see this object anymore. But down at the Dark Sky weekend, you should have no problems with this one. I can definitely still see it in my 8-inch Dobsonian at home, but we're sort of towards the edge of Auckland, so it's not quite as bad. I probably should mention here, if you want a bit more of a challenge, is it this one? No, there's quite a few other galaxies in the field, and possibly what was that one? No, that wasn't it.
We're looking at that.
Oh, hang on, here we go. I think it's this one we're at. No, not that one.
Well, it's the set that's near Centaurus A. Previous Dark Sky weekend, we were using the recently received very large Dobsonian, and it is actually possible to see them there.
Yeah, there's actually a few other galaxies around this field. That wasn't the one I was looking for, actually. Oh, it might be this one. What's that one? Oh, yeah, this is the one I was thinking of, 4945. This one's a bit more doable. I got a bit lost there for a minute. I was thinking it was near Centaurus A, but it's actually better to use Omega Centauri as a reference to find this one. That number C83 refers to the Caldwell catalogue. What happened, you've probably heard of the Messier catalogue of objects. That back in the 18th century, Charles Messier and some of his friends catalogued all of these faint fuzzy objects so that they wouldn't be confused for comets, which was what they were primarily interested in. But it became probably the first catalogue of deep sky objects. And of course, it only, because it was done from Paris, doesn't have any deep southern hemisphere objects. So Patrick Moore decided that there should be a similar catalogue to the Messier catalogue that covers the southern hemisphere. And I gather that Caldwell was his mother's name. Do you know, Steve?
I think so.
Something like that. So that's where the Caldwell catalogue comes from. So it was just a collection of objects that was put together by Sir Patrick Moore. If you don't know who he was the founder of the Sky at Night BBC television program that ran for, it still runs, but not with him, of course, because he passed away now. If you watch those shows with Chris Lintott and others, that's the continuation of the Sky at Night that started in the 1950s with Sir Patrick Moore. Yeah, so definitely have a go at these other ones. This is possibly doable in larger aperture scopes. It's 9th magnitude. You wouldn't bother here without a camera, but definitely down there in the big 18-inch Dobsonian, it should be relatively straightforward. Okay, before we move out of Centaurus, has anyone got anything else from this constellation?
5460 is decent if you can actually see it.
Which one?
NGC 5460.
Oh, that's a star cluster here.
It's quite decent.
Oh, yeah, that should be pretty easy. It's around 6 magnitude, or just a little brighter. Let's zoom in on it to see how it renders in stellarium. It looks like it's a fairly sparse cluster, but yeah, you should be able to pick those stars up quite easily. What are the individual star brightnesses? If it'll let me do that. Oh yeah, sort of 8th and 9th magnitude.
A very relaxing object for most telescopes.
Okay. What we should do, I'm just trying to decide which way to go. You see, just coming up at this time on the horizon is Scorpius. Now, we'd normally consider that as a winter constellation. There's a number of objects in there to look at. But of course, down there, you're probably going to be up to at least midnight. By that time, it'll be up at a decent altitude, so we might come back to that one. What we'll do instead, though, is go over to here. So we're looking in the part of the sky that doesn't have any Milky Way in it. Not many bright stars. You'll see a few fainter stars from a dark sky site. from the city, you'll see practically nothing. But the two objects that you will see quite clearly down there, are if we get a clear night, are the two Magellanic Clouds. So we've got down here is the small cloud and the large cloud. So we'll go to the small cloud first. There's a bit of nebula and stuff to look at in there, worth having a scan and a telescope. Unfortunately, it's pretty low at this time of night, but again, if you wait till midnight, 4 hours will bring it higher into the sky, or later if some of the people stay up till really late. But there's a couple of things I wanted to point out, is that we talked about Omega Centauri, but we've got this, I didn't mention, Omega Centauri is considered to be the brightest globular in the sky. Well, this one, 47 Tucanae, or NGC 104, you can see it's also called 106, multiple names, is the second brightest. And if you, it's actually not hard to find this one, even when you can't see the small Magellanic Cloud, because it's bright enough to shine through the sky glow of the city. Maybe trickier when it's a bit lower, like it is at this time of night, at this time of year. But if we zoom in, see a similar thing to Omega Centauri, but visually you'll notice that this one is a lot more concentrated towards the core, whereas the Omega Centauri is a bit more evenly spaced. It does get more concentrated in the core, but this is dramatically so that in your eyepiece it'll look like a bullseye, because there's just such a high density of stars in the core, you can't actually resolve them. And as you see here, it's fourth magnitude, and in fact this is another globular that can be seen with the naked eye from a dark site. You won't know that it's a globular, it just looks like a slightly fuzzy star if you spot it. And then we don't want to forget, there's actually another globular near the small Magellanic Cloud, and by the way, these objects, they have nothing to do with the small Magellanic Cloud, which is about 200,000 light years distance. The two globulars you see here, the 47 Tuc and this one NGC, I think it's 362, that's right. They're much closer, they're like maybe between 10 and 20,000 light years. Actually, does it tell us in here? Some of these things give information. Oh yeah, distance. This one's 27,000 light years. So it's only an eighth of the way out to the small cloud. If we go back to 47 Tucanae, what does it say for the distance? It's quite a bit closer actually, about 15,000 light years according to that. Because of this sort of showpiece object here, people often ignore NGC 362, but it's definitely worth a look at. If we zoom in, we can see again another nice globular, probably because it's further away, it isn't as well resolved. And then we should, if we're coming down to this part of the sky, we want to go to the large cloud. And I'm not sure why Stellarium doesn't actually bring it up as an object, which is kind of interesting. I'm not sure of the reason for that. But this, another dwarf galaxy, it's a bit closer than the small cloud. This one's about 170,000 light years away. The two of them actually have some tidal interaction with each other and with the Milky Way. But if you look through here on a large telescope from a dark site, you'll see there's all sorts of nebula and clusters, heaps of things to look at. But I guess the showpiece object is right in here. There's so much in here, I don't even know if I can select it. Oh yeah, there we go. Where's my central? So this is what's known as the Tarantula Nebula. And it's bright enough to see from here in the big telescope, but you won't see anywhere near the detail you'll see down at Waharau. And one of the things it's famous for is supernova 1987A occurred in this area, and it's the last supernova within the local cluster of galaxies, including the Milky Way, that's been seen since the Kepler supernova of 1604. So must be another one due soon in the Milky Way, I would have thought. This nebula, if it, you've probably all seen the Orion, the Great Nebula in Orion. This nebula covers about, if it was at the same distance as the Orion Nebula, which is the Orion Nebula is about 1,500 or so light years, you put this at the same distance, it would cover a third of the sky. And there's so many supergiant luminous stars in this region. The reddish colours all being caused by lots of ultraviolet light from hundreds and hundreds of basically type O and B giant stars. So it's an area where you generally will expect to get relatively lot of supernova, and there's a lot of star formation going on. Zoom back out. There's not really any deep sky object to talk about, but this star here, Achernar, or Alpha Eridani, sorry. It's basically the only bright star in this sort of region until you get nearer up to the Milky Way, where Canopus you see there. And the interesting thing about it is it's quite useful for finding your way around, because you can run a line through the Southern Cross, the long axis, down to Achernar. Actually, I should change the grid. I'll change to equatorial grid to make it a bit easier to see. See, if we run the line down to Achernar, the midpoint of the line is quite close to the south celestial pole. So if you can see these stars at night, you can use that to figure out which way you're looking if you're not sure. Achernar is really easy to see because, as you see, it's brighter than first magnitude, and it's the only star like that. So, and it never sets for us here in Auckland. It will brush the horizon, but then it starts to rise again. Okay, I'm going to now, so we've done this area. I should come back up to the Southern Cross. I was going to talk about this constellation right adjacent to the Southern Cross called Musca, which means the fly, so probably not everyone's favourite constellation. But there's some interesting things to see here. There's a couple of quite nice globular clusters. This one here, Caudal 105 or NGC 4833. And the way you can find this one is fairly easy. You'll see there's like a trapezium of stars, these 4 stars. So once you've identified that pattern in the sky, you run down the long line between the 2 brighter ones, and that globular is about 3/4 of the way down. So not too hard to find. I mean, if you've got a go-to telescope that's well aligned, then that's really easy. But if you're just pointing a Dobsonian around the sky, you have to learn to do these star hopping tricks. And there's another globular here, which is a bit fainter, but it's probably still doable with a decent aperture down at Dark Sky site. I wasn't really going to talk about photography, but one of the things, it doesn't really show up even on here. There's a bit of nebulosity around this area, and there's it'll probably let me, if I do a find, it'll probably show it. It's this area here, I think, it's a dark nebula called the Dark Doodad Nebula. but it's quite interesting to see in a photograph, because you see this background of Milky Way stars, and in the middle of it there's a sort of dark thing like a snake. And I think, was it the Sky and Telescope editor was actually down in New Zealand and photographed this area, and he saw this dark patch. It was unnamed, but he gave it the name the Dark Doodad. So that's the start. It looks as though, looking at this, it doesn't list a proper, like a dark nebula catalogue name either, so it's probably still not officially catalogued. It's only got the popular name. It's quite interesting. Now, we want to move going instead of the Centaurus direction, although Centaurus does actually curl right around the Southern Cross. So there's one object that I wanted to mention that's still in Centaurus, but on this side of it. If we zoom in, it does show it there. See the little green symbol there as the symbol for planetary nebula. And this one is called the Blue Planetary. And as we see photographs of various nebula, they have nice, like you'll see ones that have greenish colours or red colours. But if you're just looking through the eyepiece of a telescope, you never see that. Everything just looks grey, because when your eyes are dark adapted, basically the rod cells see the luminance, but the colour cone cells are pretty much inactive. So there's not enough light to get them seeing anything, so everything looks grey. So you see the nebulas of like grey clouds. But there's a few of these planetaries that happen to have a high enough surface brightness to actually see colour. And you can actually see this in a moderate-sized telescope. It's quite small in the eyepiece. A lot of these planetaries are so cool because they're round-looking objects, and they're similar angular size to the planet. So I think the name was again coined by the Herschels when they saw these. And they saw these funny little round nebula, and they said, oh, they look a little bit like ghostly planets. They called them planetary nebula. So that's where the name comes from. Now if I just centre it and zoom in and see if it renders it for us. Oh yeah. You won't see that much detail. In photography, these things often have really strange topology, and if you don't know what they are, you'll find that in the centre of one of these is a white dwarf. So this is basically a star that has died, and it's run out of nuclear fuel, final phase of burning, throws off its atmosphere, leaves a white dwarf behind, and the atmosphere just gradually dissipates out into interstellar space. But when you're looking fairly soon after that event, all of that material is still fairly close to the star, and it's being illuminated by the white dwarf, which is very hot. So it's giving off a lot of radiation to illuminate the gas and dust that it's thrown off. So that's what we're seeing there. Part of the reason for the strange pattern is because stars always have, or pretty much always have, magnetic fields. So the magnetic field is interacting with this material, causing quite strange lobes and things like that.
There's, of course, the irony that a lot of the planetary nebulas actually have got their shape from the fact that the dead star had planets. And there are often constrictions in things like the R-class nebula from that planetary claim, but it's not the only thing that's happening.
Yeah, well, the planets could have an effect on the outgassing, I guess, yeah. And most stars we know these days do have planets. So how do you find this one? Well, if you don't have a go-to telescope, it's actually one of the easier ones to find, because you notice the Southern Cross go along the short arm of the cross. And if you go just a bit less than the same distance again, is where it is. And if you've got a cell phone program, Stellarium or any of those other ones, what I found was that you can see there's like a group of these 4 brighter stars. They're fairly easy to see. They're that one isn't, but these ones are around 6th magnitude. So it forms a sort of like a, not sure what you'd call that shape, sort of like a flattened rhombus. Yeah, that's a good description. So you can, if you recognise those 3 there on a slightly bent line, and that star lets you orient which way to go, it's just off this line joining these 2 stars, and about a quarter of a way along. Not too difficult to find. Okay, now there's probably too many objects to mention in this region, where some of these stars are still part of Centaurus, but coming into the border of the Argo Navis constellations. One really nice cluster is this one called the Pearl Cluster, Caldwell 97. It reminds me a little bit of the Jewel Box, but it doesn't have the really yellowish looking star that the Jewel Box has, but it's similar sort of size and maybe a little bit more stars in it to the eye. So if we'll centre on that one. It does show 2 yellowy stars in there, but to me I didn't really notice that so much. Yeah, so you can notice along here there are, whenever you see those dotted circles, they're star clusters, and in your program you can zoom in to see if it looks like it might be interesting to look at it. Some of them are quite sparse, maybe not so interesting, but this is an area even just to explore with a pair of binoculars. You can go all the way along here. We're coming into a fairly famous part of the southern sky. We have here this nebula area here is called the Eta Carina Nebula. And before we get there, there's one particular star cluster that I should point out. Is this one here called the Wishing Well cluster, and this is a really bright cluster. You notice magnitude 3. It's pretty much you can see it with the naked eye, but again, not as a cluster. It'll just look like a little fuzzy looking star. If we centre it and zoom in, this cluster is actually better in a small telescope because it covers quite a big area and it's very rich in stars. The name Wishing Well, I think, comes from, when you look at it, it looks, or somebody imagined that it was like coins shining in the bottom of a wishing well. People had thrown a whole lot of silver coins in there. So that's where the name comes from. But you see there's a few other names that people have given it: the Pincushion Cluster, Firefly Party Cluster, because they thought it looked like a whole lot of fireflies. So that's one of the richest open clusters in the sky. And then we'll move over here. We have the Eta Carina Nebula. And pretty sure, Rolf showed some of this last week, didn't he? Some images of this area. And he was studying light echoes. This bright blob in here is Eta Carinae. It describes as an eruptive variable star. And one thing is, when it had its outburst back in the 19th century, the star became almost as bright as Sirius. Not quite that bright, nearly as bright as Sirius. So it was basically, for a while, the second brightest star in the sky, had a big outburst, and then it gradually faded over a period of months until it got down to being barely visible to the naked eye, or even below naked eye visibility. It wasn't though a supernova or a normal nova. It has been heavily studied, and there's this really nice space telescope, Hubble Space Telescope image of it showing two lobes of material that were blasted out in this big eruption. The studies have shown that it's actually not a single star, it's a binary, believed to be two stars of approximately 80 times the mass of the Sun, probably at least one of the stars nearing the end of its life, and it's become a pretty unstable system. Eventually both of those stars will go supernova, but nobody knows when. You can see this pattern of dark nebula here. Apparently that used to be more obvious than it is these days. It's called the keyhole, or the keyhole nebula. And you can see that's sort of the round part, and then the slot that the key goes in right next to the star. And of course the wide field views show these nice dust lanes that sort of bisect the nebula. And as you see, there's other... actually I should mention this one. This is quite interesting. This one here, this star here, will it let me select the star, or do I have to zoom right in? Oh. Sometimes I have trouble actually selecting stars when no, it won't let me do it. So the star there is part of Carina. So, but when you zoom in and look at it in binoculars, you can see that it is actually a cluster, and it's referred to as the Southern Pleiades because it looks, although the pattern is a little bit different, it's reminiscent of the Pleiades or Matariki cluster on the northern side of the sky in Taurus. So, yeah, it's always a nice thing to have a look at. Probably best in a small telescope or binoculars. If you've got a 20-inch Dobsonian, don't bother with it, because you'll only see the central part of the cluster, or any long focal length telescope. And then what I might do is there's several. You can see there's lots of other star clusters all over the place here. The Whirling Dervish cluster, I hadn't heard that name before. They make up all sorts of funny names. Hand cluster. That one, Malot 98, is quite a nice one again for a small telescope. And you'll see what I would recommend you do is just trail through this area, because there's quite a lot of things. Not just star clusters, but interesting patterns of stars. You might see a little bit of faint nebulosity, worth just a general exploration. Now, the other thing I wanted to do is come over to Pappus. Actually, before we do that, I'll just point out some things here. We talked about the Southern Cross, or the Southern Pleiades here as part of, I don't think it shows it very easily, but it's part of what's called the Diamond Cross. And then you have another cross here, called the False Cross. And that is this star here, which is Avior Aspidisci, some interesting names. So if you find the false cross, it's because there's so much other stuff on here, it doesn't stand out as obviously as a cross, but I'll try and draw it. There's a really nice cluster here they call the Southern Beehive, sometimes called the Diamond Cluster, or it's called the Sprinter as well. And that's another really nice cluster to view with a small telescope. So we'll zoom in on that one. See, this is another quite rich star cluster. And you can actually again see it with the naked eye. If you look off the end of the false cross, you'll notice there's this little fuzzy star there. When you put your binoculars or telescope on it, you can see, oh, that's a star cluster. Is anyone, before we leave this particular area, has anyone else got any favourites along here?
I had a question actually.
Yeah.
You mentioned the second brightest star had the outburst.
Yeah.
When was that noticed?
In about something like 1860 from memory.
Okay. So, but how long ago did that actually happen?
Oh, yeah, well, the star's about 7,000 light years away, something of that order. It might actually, sometimes these programs tell you the distance. So if we can get it to select the star, that might be here we go, Eta Carinae. Does it give us the distance? Sometimes they do.
I don't know how many years that would be.
Well, yeah, just add 150 odd years or 160 years onto 7,000, I guess. It doesn't actually tell us here, but I vaguely recall reading it's something of the order of 7,000 light years. So at the time, being able to see a star at that distance, that was the most distant star that could be seen with the unaided eye. At the moment, you can't. Apparently, at the moment, it would still be bright enough just to see it with the unaided eye, but it's still surrounded by all the material from that outburst, which dims the star quite a bit. The material is sort of a bilobal thing, and it's called the Homunculus Nebula. You can see the brighter of the two lobes in a small telescope, so that's something to look out for. It's very small nebula, right. It's still right attached to the star, because the nebula is expanding at much slower than the speed of light, of course. So it's physical material that's being blown out.
Do I have a beginner question?
Yeah.
Why are these stars named like NGC something something?
Well, that's not stars. That's basically deep sky objects. It means New General Catalogue. Yeah. It was compiled by a guy called Dreyer back in the 19th century. As I mentioned, he used objects that had been discovered by the Herschel family and some others. And the idea was it was an all-sky catalogue of all of these. They didn't actually know at the time they were looking at galaxies. They just called them nebulae and star clusters. So the full title is the New General Catalogue of Nebulae and Star Clusters. And the problem with that, the way they did it, is that they assumed that all objects had been found. So the objects are ordered in right ascension. So if you go, say, for NGC 2, NGC 3, those two objects are adjacent to our other in right ascension. But the problem is, what if you discover another object in between them? Then you've got a problem, because do you have NGC 2.5 or 2.25 or something? So what they did when photography was invented, they could start picking up a lot more objects. And so another catalogue was developed called the Index Catalogue. And that was basically like an appendix to the NGC catalogue. So you'll see some things that are called IC something or other. And those ones are basically an add-on to the NGC catalogue. There's about 10,000 objects, I think, in the NGC catalogue. So a lot of them are very faint, but they were basically discovered visually, but with quite large telescopes and from really dark sky areas. The southern ones mostly from Cape Town, but some were done from Sydney by, remember the guy's name in Sydney? Dunlop in Sydney, I think. So they made these catalogues. And then, of course, when you started to get better photography, there were just so many of these things. They split them in newer, fainter ones into different catalogues. Like there's the principal catalogue of galaxies, which is PCG, and there's various other catalogues that were made up. Gets confusing because some of them are in more than one catalogue, so you're not quite sure which one name to use. And of course we have popular names for things as well.
I've heard that when someone discovers a new star in the sky, you can name whatever you want. If it's named that way, then how is it possible?
Not with stars. The rules are if you discover a comet, it gets named after you. If you discover an asteroid, it's not named after you, but you're allowed to suggest a name. And generally, as long as it's not a rude word or something, they will normally accept it. Like there are 3 asteroids that were discovered in the observatory here, and there's one named Auckland, one Maunga Kea, and another one, there's a third one, can't remember what it's called. Named after a pop star. Springsteen, that's right. Because the guy that discovered it was the director here, and he was a fan of Bruce Springsteen. So he suggested the name Springsteen for his asteroid.
Well, there's another fun pair. For a brief while, the asteroids Eris and its moon Dysnomia had the original names of Zena and Gabrielle.
Oh, okay. Yeah, in the TV program. Yeah, the other person in Auckland who's discovered an asteroid is Jenny McCormick, who's a home observatory out at Farm Cove. And the asteroid she discovered, she wasn't looking for asteroids, she was doing astrometry basically. And she happened to notice her subs had captured an asteroid, and that one she called, it suggested the name New Zealand, because there was no asteroid New Zealand, so now there is. The thing is, amateurs rarely discover them anymore because they have these automated survey scopes that go down to about 24th magnitude. There's no way that amateurs have got a chance to compete against that. Although the second interstellar object was discovered by an amateur, but he did a bit of a trick by looking in the twilight sky where the pro telescopes can't look. So that was Comet Borisov, which was an interstellar comet. So you can still beat them, but it's tricky.
Bill, do you know what the convention is for the Gaia number?
The Gaia catalogue is so big, it's broken up into regions of the sky. Like, I think there's something like 1.6 billion stars in it. So
That's what I was thinking, because the number is
yeah. Yeah, it looks like Gaia DR3 and then a huge long telephone number. I think the way it works, it isn't a simple numeric thing. I think part of it identifies the region of the sky that it's in, and then I don't know how they do the numbering within the region. It might be sort of, I'm not actually sure about that. It's an interesting question. If you want to download, the Gaia catalogue is publicly available. It's something that's with 1.5 billion stars in it. And each star, it's got all sorts of information on its brightness, its proper motion, position in the sky. So it's got RA index to high precision. It's got colour index and various other bits and pieces. So because of that extra information, the catalogue is quite big. So people generally just download a part of it for a particular region that they're interested in. Where did we get to? We've still got, we probably think of these stars as more early autumn, late summer, but we've got the region of Sirius. And there was just a couple of things I was going to talk about here. Right in the belly of the dog, or Canis Major, is this nice cluster here, Mesia 41. Which is, I hadn't heard the term little beehive cluster before, but I'd just known it as the Mesia 41. But that's sort of in the heart of the dog, if you like. But I didn't want to talk about, you can see there's so many clusters along this coming through Papas to get to Canis Major. There's just an area that you should explore. Unless somebody's got any particular objects they'd like to mention coming through Papas. Well, there's a couple I will mention because this is quite interesting. You've got two clusters that are quite close together in the sky, Messier 47 and Messier 46. Now, 47 is fairly easy, is quite bright, and the other one, 46, as a neighbour, is quite a lot fainter. But you can see them both in a sort of moderate-sized telescope, and obviously that one you can actually just make it out in binoculars. But if you want to see any detail, you need a telescope on it. But this one is quite interesting, this Messier 46, because there's actually a globular cluster inside. Not a globular cluster, planetary nebula inside the cluster. And we used to be able to see that in the Zeiss, didn't we? I remember one night we had a dark night with really good seeing, and you could see this round greyish blob. There's no colour in this one, right in the middle of this cluster, so that could be an interesting challenge to try and see down at Waharau. There's another one there, this globular here, called the Calabash Nebula. Notice that one is 9th magnitude. So they're similar brightness, but I've found that one is actually a lot harder to see. And it may be, the way they quote magnitudes on these is that it's the integrated magnitude over the whole object. So a small object with a lower magnitude might be easier to see than a large object that's actually a brighter integrated magnitude. The way they do it is like an integration of the brightness over the whole area. Sometimes if you want to know whether you can see something, rather than look at the magnitude of the object, what you want to know is its surface brightness, which is brightness per square arc seconds. And you notice that stellarium does tell us that. So the total magnitude is 9 for this one. And it's 9 magnitudes per, that's per arc minute, so that's over quite a large area. So that one is quite hard to see. Right, it's getting later than I thought. I must have been rattling on too much. We will do a few things on the quickly do a few things on the northern sky, because we have coming into view in the earlier part of the evening. There is actually the Beehive cluster, which I should mention. So this is the this area here is the constellation Cancer, the Crab. Fairly nondescript looking stars, but at the moment you've got a convenient positioning of Mars in the Cancer. So that'll help you to find it, and the Beehive is quite a nice cluster in binoculars or a small telescope. So we're looking at the northwestern sky, and you notice it's getting towards setting, and it's 9 o'clock. So yeah, so that, this stuff that's sort of getting towards the west, you want to be observing that in the earlier part of the evening, so that at least it's still relatively high when you look at it. Like the Orion Nebula is still up, and it's getting dark by 6:30 or 7. So yeah, if you want to view any of these objects, do it early before they set, and they're still at a reasonable altitude. The other thing I should mention is the constellation Leo. You can see the sickle shape there, and there is a nice set of galaxies in here. See as we zoom in, and these ones are particularly well known, called the Leo triplet, Messier 65, Messier 66, and this other galaxy doesn't have a Messier catalogue name, but it does have an NGC number, remember I mentioned PGC, Principal Galactic Catalogue or something. Oh, and you see there's some other ones there that I didn't mention. The ARP one is interesting. Halton ARP was a bit of a maverick astronomer, and he decided he was going to go through the sky and catalogue all of these objects that other astronomers couldn't explain. So that's basically the ARP catalogue. And there are things usually where you had galaxies interacting, so they were all sorts of weird and wonderful shapes because they didn't fit into the normal pattern that they had of ellipticals and spirals and lenticulars and this sort of thing. He said, oh, hang on, what about these ones? And generally with better telescopes, they're found to be interacting galaxies, which is why they had bizarre shapes quite often. But he was trying to challenge the orthodoxy. But as you see here, this is really particularly rich in galaxies, so definitely a fun place of the sky to look at. And then we're getting, as we're coming over this way, we're getting into even richer area of galaxies as we're getting into the Virgo cluster here. So Macarian's chain is a chain of galaxies. So Messier 86 and a number of others. So before we leave it, I did definitely explore this area. The best time of year to explore the richest part of the sky for galaxies, the Virgo cluster and around the border of Leo. Oh, and one really easy one I should mention is this guy here, the sombrero one. Now, to find this one, some of those others quite tricky to find, but you've got some stars there you can see quite easily if you use your star chart or your, if you've got a phone with one of these programs or laptop or whatever, you can zoom in to find your way using the adjacent stars. But this one is particularly easy. Before we had GOTO on the Zeiss, we sort of knew this one off by heart, because what you would do is you'd come down from Corvus, which is really easy to make out on the sky, even in Auckland. You make way down until you find this little triplet of stars here that's got a slight, looks like an arrowhead, if you can imagine that, coming from this star. You follow that arrowhead down and you'll find another group of 3 stars that point directly at the galaxy. And this one and this one are easy to see in the finder scope of your telescope. So that's how you find Messier 104 or the Sombrero galaxy. It's another one of these galaxies with a dark lane in it. But this one doesn't look as, it looks a bit more regular than the Centaurus A galaxy. It's not as disturbed, obviously, but it has the dark dust lane. So that's another good object to look at in the northern sky. Oh yeah, there was one object I actually forgot, which is actually in Centaurus, but it's right on the constellation border, is this one here, Messier 83, or the southern pinwheel. So this is a face-on spiral. So it's a very favoured photographic object, but definitely from Waharau you should be able to see at least the faint fuzzy as they refer to these things. Okay, that's probably enough exploring the sky for tonight. There's actually a lot more. We haven't got time to talk about it all, but hopefully those going down on the weekend have got some ideas of things to try to look at, or even if you just in your backyard, some suggestions for objects. This is actually the best time of all time of year, with so much choice of different astronomical deep sky objects. So any questions or points you'd like to bring up? No? Oh, well, just thanks everybody for coming.